Hi grade 11s. I hope everyone is well and safe and using this time to revise some maths so that hopefully when we all get back together we've got a good foundation to kick off the rest of this year. What we're doing with these videos is we're going to be looking at some exam type questions, because in grade 11 and grade 12 really we've got to be able to take exams well. We've got to be able to make sure we maximize our potential and we get all the marks that we possibly can from an exam. So I'm starting off with question 1, and this document is available in the link in the description below. So as I go through question 1 here, this is just a mock exam. I hope that you're going to try this before you watch me go through it. But I'm going to do two things. The first thing I'm going to do is I'm going to analyze what do we normally ask you in question 1. And guys, this question 1 in your grade 11 exam is going to be almost identical to question 1 in your grade 12 final paper. There's always a little bit of variation from one year to another, but there's going to be so many of these questions that you're going to see again and again and again and again. So this is the first question that you're going to write in your exam, and you want to make sure that you get off to the best start possible, that you get your confidence up, and that as you go through the rest of the exam, you knowing that you've done well in question 1 with these algebraic skills that everyone can practice and get really good at. Okay, let's look at question 1. Let's look at the types of questions and importantly the mark allocations, because the mark allocations always give us an idea of just how much work is going to be required. And so you can plan your time carefully and you can see some things that when they initially look difficult, they might not be worth spending time on. So if we look at question 1, the first thing we look at is the instruction here that says solve for x. And if we're asked to solve for x, we realize that that means we're asked to do equations, we're asked to find values of x. And that normally means our final answer is going to be x equals, but in grade 11 we realize often we're going to have more than one answer. X equals something or x equals another thing. And if we look at question 1, what type of equation have we got here? Well, maybe it doesn't immediately look obvious to you, and your first thought might be to go and distribute in. And if you go and distribute in, you're going to get 12x squared, which means you've got a quadratic equation, which we normally solve by either factorizing or your formula. However, look at the mark allocation. It's only 2 marks. And if you take a second look and you look closely, you realize that this was already factorized. Your factors are 6x and 2x plus 1. In which case, you're looking for, does this factor x equals 0, or does the second factor 2x plus 1 equals 0? That's why it's only 2 marks. So just look at the question with the mark allocation and see how much work is required. Okay, if we look at the next equation, we see 2x squared, right? So this is an equation with 2x squared. So it is a quadratic equation. But look at this thing that jumps out at you here. They want to solve for x correct to 1 decimal place. So when we're thinking about solving for x, and we see here, well, 1 decimal place, that means that the solutions are going to be irrational. And the only way to find irrational solutions is by using the formula. So as soon as you see an instruction like 1 decimal place, 2 decimal places, third form, and we've got a quadratic equation, we know immediately that we're going to use the quadratic formula. We're not going to even try and use the quadratic formula. Now, while I talk about the quadratic formula, it is really good. As soon as you get your question paper, why don't you write down your quadratic formula so that you've got it once here. And whenever you need to use your quadratic formula, you go back and refer to it here, almost like a formula sheet. Remembering here with your quadratic formula that if you're going to have A and B and C, we can only talk about A, B, and C if we have it in standard form. So think about where those marks are going to come from. Think about your strategy. You want to get into standard form. Use your quadratic formula and you're going to get 2 solutions. All right, let's look at the question 1.1.3 for 5 marks. Okay, this tells us we're going to do some work here. And what needs to jump out at you immediately is that you've got a square root or a surd. This is a surd equation. And your first thought of surd equations is, oh, okay, well, we're going to square both sides. But before we can square both sides, we must isolate that surd. Is my root here isolated? No, I've got plus x. So I'm thinking that before I can worry about squaring both sides, I have to get that square root by itself. The other thing, just to make a note of when you're looking at these questions, with surd equations, we always have to check our solutions, because in squaring both sides, we may introduce new solutions which are not valid back up in this original equation. So whenever we get solutions for 1.1.3, we need to go back and check that those solutions are valid. All right, question 1.1.4. What jumps out at us? Well, we've got another quadratic, but now we don't have an equation. We've got an inequality. We're looking here now for a range or an interval of values. Something like x is between these numbers, or x is greater than this number. And how do we find that interval of values? The most important thing is you're looking for critical values, and then you either need to use some sort of number line or the graph to find out where are the values that will satisfy this inequality. It's going to be similar to your standard form here, that you're going to need to factorize in order to find your critical values. But you must have this awareness that you're not going to use the same procedure as you did for 1.1 and 1.2. You need to go and look at the graph or the number line to find the values that satisfy that inequality. Okay, 1.1.5. What jumps out at us here? What type of equation? Look at where x is. X is in the exponent. This is an exponential equation. And how do we solve exponential equations? Well, we normally get that base with an unknown exponent, and on the other side we try and get the same base with a different exponent. So here I'm going to try and get down there, but the other thing that we have to notice is that we've got more than one term. And if we think about our exponential laws, all of them work with multiplication and division of powers. As soon as I've got addition or subtraction, we need to think about factorizing. Okay, this is your more difficult question. Okay, you can see that this is a little bit unfamiliar. They've given me a clue here that looks like a factor already to me. One other thing, as soon as we're working with exponents, is that I want to be working with prime bases as well. So those are some of the ideas that you need to try and apply to 1.1.5. Okay, let's look at 1.2. Let's look at the mark allocation for 1.2. You've got 6 marks. Now that obviously means that you're going to have a bit of time here. You need to be careful. Do you know what to do? Solve for x and y simultaneously. So now we've got an equation. Now our answer is going to be x equals this number and y equals this number. And I notice because of the squares, we might have another pair, or x equals this number and y equals this number. Another pair of solutions. Okay, how are we going to solve for 2 unknowns? Well, remember that we want to try and substitute either for x or for y so that we have an equation that has only one letter. And how do we do that? Well, we want to normally write the linear equation as either y equals, although it doesn't look that easy here, but this looks like we can easily write it as x equals. And then once we've got it as x equals, we're going to go and substitute everywhere that we see x. We need to replace it with whatever our expression is that has y's only. Then we're going to solve for y, and then we can go back and solve for x. Okay, the tricky thing about these 6 marks is you must be careful with your algebra. If you make 2 errors, then we can stop marking. Okay, so as long as you have your strategy right and then you are careful, you're going to get nice 6 marks there. Alright, question 1.3. This one looks a little intimidating to begin with. If f of x is equal to 0, what does that mean? F is a function. If f of x is equal to 0, what happens when we make a function equal to 0? Well, these are like finding our x-intercepts, but it's also what we call the roots of the function. That's what comes next. It says that the roots are x equals -5 plus or minus the square root. Hey, this structure here looks very much like my quadratic formula. Negative b plus or minus b squared minus 4ac. For which values of k will the roots be non-real? Now, there's this word again, roots and non-real. And hopefully when you're thinking about roots and non-real, you're thinking about delta. Delta is b squared minus 4ac. And non-real roots, delta is negative. That's how we write negative. But now, where do I have a, b, and c? I can't see exactly what a, b, and c are here. B squared, does that mean b is the root of 3? Negative b? No, that doesn't quite look right. So obviously this is some other expression here for delta. Delta is equal to 3 minus 12k. We're not going to try and find a equals, b equals. We don't need to know that. We need to know, well, that part under the square root is delta. And so if I can find this and make that less than 0, then maybe I can find, oh, what values of k? My answer therefore needs to be if k is this number, or if k is less than this number, or k is greater than. Right, question 1.4. Now, something else to bear in mind, and it doesn't always happen this way, but often within a question 1, the questions may get more difficult as we go on. And so often question 1.4, we may expect it to be slightly more difficult than the other questions. And certainly when we begin to read question 4, it does look different to what we've seen before. Let's read it and try and make sense of what it means to us, given that -4 is less than x and x is less than 3, and y is greater than -5, but y is less than 4. What are they giving us here? Well, they're giving us here with x, they're giving us almost like restrictions. They're telling us x is some number between, x is greater than -4, but x is less than 3, so that means x is between -4 and 3. And then they're giving us some restrictions here for what y is. They're telling us, well, they're telling us that y has to be between -5 and 4. So with all we're doing now, they've set those restrictions up. Right, let's go and look at the questions they've asked. They've said, determine the largest possible value of x squared. So that means I'm looking at my values of x, and I'm thinking, if I take these numbers from -4 up to 3, including those endpoints, and I square it, how do I get the biggest number? Obviously, big numbers, positive in this case. And if I square negatives, well, I'm going to get positive answers. So I'm looking at -4 squared, 16, -3 squared, 9, that's smaller. -2 squared, that's 4, -1 squared. These answers seem to be getting smaller. If I take this extreme end here, 3 squared is 9. So maybe I have an idea now of what the largest possible value of x squared is. Now it says the smallest possible value of x times y. So now we're looking at a value of x, so one of those pink numbers, and we're looking at a value of y, so one of the green numbers, but now we want to make it small. Now, what's the smallest possible number? Well, it's not necessarily 0, because I know from my knowledge on number lines that numbers to the left of 0 get smaller. So in fact, what am I looking for the smallest? I'm looking for the biggest negative, if I can say it that way. I'm looking for the number which is the furthest left. And I need to choose a number from the set of x and a number from the set of y, and I need to multiply them. How do I get big negatives? Well, I probably want to have one of these as a negative and the other one as a positive. That's going to give me a negative. So how can I get the biggest result from choosing one of them as negative and one of them as positive? Okay, the last one. The value of y. Okay, so we're going to solve for y if y squared. So now I'm looking only at my y values, and it says y squared is equal to 25. So what can I square that I get 25? Well, I can get positive or -5. If I square that, it's going to give me 25. But are both of those in the set of y? Okay, so now we've seen how we can decode or break down question 1. The important thing to notice here, your banking marks, the questions that you have to begin with, that you have to prioritize. You are looking at 1.1.1, 1.1.2, 1.1.3, and 1.1.4. All of those are absolutely straightforward procedures that you should have practiced many, many times. Question 1.2 as well. There's nothing unfamiliar there. We've definitely practiced those ones before. So you've got there, that's 6 plus 4 is 10, 19 plus another 2, 21 marks. 21 of those 33 marks are straightforward. Then with the rest of them, you're going to try your best. You're going to fight for as many marks as you can. Okay? In things like this, you need to use the clues. What do I know? Nature of roots, where's my delta? Can I see that there? You're also not going to get caught up on this last question. If you read that and you didn't understand what the notation meant, you couldn't see what they were asking, this is only 4 marks. 4 out of 33, that's not a lot of marks, but remember, we're actually looking at a total of 150 for paper 1. So you're looking at 4 marks out of 150 marks. You do not want to spend a lot of time on this if you don't know what's happening there. Rather move on, bank all the marks that you can, and then come back at the end when you're feeling like you've done your best, and now you try and get as many marks from these other equations as possible. Okay, so I'm going to leave it there for now. The next video, I'm going to work through the full memo of these questions. Again, I hope that you've tried these questions, and then you can use the next video to see where you get stuck.